Hey guys, this is your semester exam review part 1 out of 3. I'm going to try to break it down into 3 separate parts. This is for your Algebra 2. I am Sensei, or you know me as Miss Pasquale. My helper over here is Mr. Jimmy Alvarez.
Get my Nintendo back.
After you help me. Anyway, guys, this review is very important. We structured this review so that it's covering everything that's going to be on your midterm. So please pay very close attention. We are here to help you.
Can I please have my Nintendo back?
No. Given the following functions, name the domain and range. Domain is the set of x values, meaning we're going to be scanning the graph from left to right, meaning from the negatives to the positives, from smallest to largest. For your domain and range, we have arrows, meaning I know for certain there's going to be some infinity somewhere. Scanning the graph from left to right, my graph starts off all the way on the left side. We automatically assume that, hey, because of this arrow, it's going on and on forever and ever this way. So at all x values to the left, all negative real numbers, all the way to when x is positive infinity. That is where my graph exists. So guys, remember in domain and range is specifying an area of where your graph exists. So think of it as like an iPhone. You see a picture, you want to zoom in, you're only interested in that picture. So in domain and range, we are only interested in where the graph exists. For your range values, and in your y values, you start from the bottom, from negative infinity all the way to positive infinity. You start from the smallest to the largest, from the negatives to the positives, because you started from the bottom, now you're here. Scanning your graph from bottom to top, my lowest point, my lowest y value is at -3. And as I scan the graph, my graph still exists on and on up until positive infinity. Right? -3 is included in my range because of this closed circle, and infinity is never included because it is a concept. It is not an actual number. Infinity will never be included. That's why we put the parentheses instead of the brackets. Brackets denote that it is included in your domain or range. In your domain or range, the only time when it is not included is if there's an obvious open circle or infinity, negative infinity or positive infinity. A good way to start this off is to create a window of where your graph exists, a rectangular window. So on the left side, we see that it begins when x, remember domain is your x values, it begins when x is -3. And it continues all the way until your rightmost point, which is x is 5. On the left boundary, we have an open circle. That means it's not included, so I put the parentheses. And on my rightmost bound, there's a closed circle. Therefore, I put brackets denoting that it is included. For your range, you scan from the bottom to the top. So we're looking at the lowest value on my graph in the y values. That's when y is -4. And again, because of this closed circle on the lower bound, I have it to be included in my range. And my highest bound, just because there is not a defined point, does not mean that this is not included. The only time it's not included is when there's an obvious open circle, like right here, or any sort of infinity. So arrows. But it ends here when y is a +3. It is included in my solution. Create a window of where your graph exists. Over here, I have an arrow, so I'm just assuming that it's going on and on forever and ever this way. I have a left bound, and I have a lower bound. So my leftmost bound is when x is a -4, and it continues all the way to infinity. Oh, and this is included because of that closed circle. And then for my range, my lower bound is when y is -3, and it goes all the way up to positive infinity. Not included.
1 down, 39 to go.
El número dos. Find the range given the specified domain. So we're still doing domain and range, except this time we're not given a visual graph. We are instead given a function. Normally, this is a graph of a line. And in a line, our domain and range, they're all real numbers. However, because we are given a specified domain, meaning domain I have x values, so when x is equal to 0, when x is equal to 1, and when x is equal to 2, if they give me a specified domain, I need to give that corresponding specified range. So the easiest lazy way out to do this is to use your tool, your graphing calculator. Go to y equals, plug it in, go to your table values, go press second and graph. Right. And remember, you can scan through your table. So we want to find the corresponding y value when x is 0. That corresponding y value is -10. And when x is 1, y is -8. And when x is 2, y is -6. So again, given the specific x values, the specific function values, you can simply use your calculator to evaluate the corresponding y values. All the calculator is doing is plugging in these x values in place of x, and then evaluating that expression to find the corresponding y values. For example, this one right here, f of 0 is equal to 2 times whatever my x was, which was 0 minus 10. 2 times 0 is 0, and 0 minus 10 does give you a -10, which matches my corresponding y value. So again, just the easy way out is just use your graphing calculator as a tool to set up the table. Doing the same process, but for the next one, go to your y equals, plug in that function. Go to your table. Now the corresponding y value when x is 0, y is 4. When x is 1, y is 6. And when x is 2, y is 20. And there you have your specific range values for your specified domain. Number 3, so we aren't given a specific or concrete equation. We just know that we have a graph and it's called f of x. So this is going back to transformations. We had multiple types of transformations. Let's review. Let's say I add a number or subtract a number to our function. What that does is it either shifts the graph up or down. Let's say that I have inside my parentheses, I added or subtracted a number. This is the horizontal shift, meaning you shift the graph either left or right. But remember, insiders, they lied to you. So whatever's inside the parentheses, if they added a number, it'll move to the left. If they subtracted a number, it'll move to the right. If you multiply your function by a negative, what that does is it reflects downward. If you multiply your function by a number, what that does is it either compresses or stretches your graph. So considering these different types of transformations, on the first row we have f of x minus 3. That is a vertical shift. Because it's minus 3, it shifted down 3 units. Over here on the second one, -2 times f of x, they multiplied by a -2. This negative reflects the graph, whatever it is, reflects it downward.
Across the x, right?
Yes, across the x-axis. And because they multiplied by 2, that compressed the graph by a factor of 2. Insiders, they lied to you. So, inside the parentheses, that denotes a horizontal shift. It says here, oh, we're going towards the negatives. But no, we know better than that. It is towards the positives. So, it went to the right 4 units. And on the last one, there are 2 different types of transformations going on here. Again, on the inside, that's my horizontal shift. I am going not towards the positives, but towards the negatives, 5 units. So to the left, 5. And on the outside, they don't lie, up 4 units. And those are your transformations. So if you were to remember these 4 main transformations, you'll do fine. Alright, so for number 4, they give us a set of points. This is along the x-axis, and this is along the y-axis. So go ahead and plot those points. Once you have plotted all your points from the table onto the graph, your graph should look something like this. So you can go ahead and connect these dots. So this is going back to the unit that we did on parent functions. Remember, we gave you this entire handout front and back with all the different types of parent functions. We had linear, we had quadratic, cubic, logarithmic, exponential. What we're supposed to do on this one is to see which one of the parent functions best models this data. This can go either one of two ways. You can either say it's the quadratic, or this could also arguably be exponential. So it's just a matter of recognizing what the parent function looks like. So basically numbers 5, 6, and 7, all transformations. So pretty much what you're doing for number 5, you're going to do the same thing for number 6 and number 7. And this is going back again to transformations, right? So as you look at all of these, we don't have to worry about multiplying by a factor because we see that the size, it didn't really change. All we're dealing with is different shifts of the graph. So the best thing to do here, and you can pick any point, use reference point. I'm going to just use this peak right here. We can see where it shifted on the graph based off of those reference points. Alright, so this one, I chose this point at -5, 4, and it moved to -2, 2. Right, so this is the x values, and this is the y values. I don't know the specific equation for this weird graph. All I know is that it's called f of x. So again, going back to that rule, those 4 rules of transformations that I showed you guys. Looking over here, I'm going to set this up, f of x something, alright? So from this graph to this graph, I moved from when x is -5 to when x is a -2. That means I moved from this graph to this graph, I moved to the right 3 units. And I know for the horizontal change, it's inside of my equation. I'm going to either add or subtract inside of the parentheses. But insiders, they lie to you. So instead of going towards the positives, you're going to say, oh, I'm really going towards the negatives. And from this graph to this graph, it shifted from when y is 4 to when y is 2, meaning it went down 2 units. So on the outside, outsiders, they don't lie. Same thing here on number 6. On number 6, I'm going to choose those same reference point. It was at -2, 2. And this one over here was 0, 7. From this graph to this graph, I shifted to the right 2 units. Looking at my x values, my horizontal shift, I shifted to the right 2 units. So inside of my parentheses, that's my horizontal shift. To the right is towards the positives, but oh, insiders lie. So I'm going to say, hey, it's towards the negatives. And the graph not only shifted to the right, it also shifted up. How much did it shift up? From 2 to 7, it shifted up 5 units. Number 7, picking these 2 reference points from this graph to this graph, it moved to the left 5, so towards the negatives, but oh, it lied, so we say that it went towards the positives. So inside the parentheses, x plus 5, and then it moved down 4 units from when y is 7 to when y is 3. Because it moved down, it's -4 units. Now number 8. Now don't freak out. Remember, when we have these types of systems, we can use what is called our matrices. And in our matrices, it's pretty simple, but remember, you want to make sure that before you input your matrix into a calculator, you want to make sure that it's in the format x's, y's, z's equals number. Okay, remember, x's first, y's, and then z's equals number. You want to have it in that form because when you go ahead and put it in a matrix, we're only considering the coefficients of each of them. We are taking out the variables, so we want to make sure it's in the correct column. Alright, so first, whenever we're setting up our matrix, we look at the coefficients, meaning the number that's next to the variable. For my x column, I have 8, and then if there's not a number there in front of the variable, we automatically assume it's a 1, and then I have a 2. In my y columns, I have 2, negative 5. Remember, if it's a minus sign, we take that as a negative 1. And then for your z column, it's negative 3, 4, 1. And don't forget that last column, 20, negative 22, and 3. So guys, be very careful whenever you're transferring your numbers from the equation back into a matrix, because one wrong number and it's going to be all wrong on the calculator. So I'm going to go over how to input this into the calculator. Second, and then this X inverse key, or above it, it says matrix. What we want to do is we want to input our matrix first. So I'm going to highlight where it says edit, and I'm going to press enter because I want to edit matrix A. Now looking at my matrix, 3 by 4 matrix. We do it rows first and then columns. So that's what you want to specify on your calculator, 3 by 4. Enter. And then you just simply want to enter it from left to right. 8, enter. 2, enter. Negative 3, enter. 20, enter. It enters it from left to right. Resets to the next row. Right, once you have all of your numbers entered into your matrix, go to second mode. Don't panic, it did not erase. You need to go back to second matrix. Now you want to tell it to do the math. Highlight the word math. And then what you want to do is you want to press the up arrow because it's going to be option B, R-E-F. And now you want to specify which matrix to do the math on. So you have to go back to second matrix and then just press enter. Press enter again, and there you have it. The first one is your X, the second one is your Y's, and then the last one is your Z's. That solution, when you plug in those corresponding X values, Y's, and Z's back into these 3 equations, that should satisfy. All of those will be true. Moving on to number 9, it says here to solve the following systems of equations by graphing. Now this is going back to what we first learned this year in Algebra 2. We solved equations by graphing. We also solved equations by substitution and elimination. Make sure that each of these equations is in the slope-intercept form, meaning y equals mx plus b, where m is your slope and b is your y-intercept. Whenever you're plotting lines, there's 2 main steps. First, plot your y-intercept, and then from that reference point, do the rise over the run. So let's look at this first one. My y-intercept is at 3. Right away, I'm going to plot my y-intercept at 3. And using that as a reference point, I'm going to do my rise over run for my slope. And if it's not in fraction form, force it to be a fraction by putting it over 1. So that means I'm going to have to rise 2 and run to the right 1. So from this point, rise 2, run 1, and keep going, rise 2, run 1. Or if you have any 2 points, you can form a line. The y-intercept is at 8, so I'm going to plot it at 8. And my slope this time is a negative 3 over 1, meaning I'm going to drop 3 and run 1. So from that y-intercept, I'm going to drop 3 and run 1. Oh, there's a solution. Drop 3 and run 1. So whenever you're solving systems of equations by graphing, the solution to a system, that's where they share a common point, meaning that's where they intersect. And in this case, they intersect at 1, 5. In the case where you don't have to graph it by hand, just use your graphing calculator. Go to your graph. It graphs it for you. And you can tell it to find the intersection between those 2 graphs just by going to second trace, that's the calculate function, and we want to go to the 5th option, which is intersect. And all you have to do is press enter 3 times. And that gives you the intersection at 1, 5, which is right there what we just found. Alright, on to number 10. I believe that the best strategy here is to draw a picture. It says here the side x of a square. Alright, so let's draw a square. And it says the side is the length of x. So that means because it's a square, the other side has a length of x as well. Equals the width of a rectangle. So, I also have a rectangle. I'm going to draw a rectangle, and its width is that of the side of the square. And It also says the length of the rectangle is 6 meters longer than its width. So the algebraic expression that matches that statement would be whatever your width is, which is x, plus 6. It's 6 meters more than its width. It also says here the sum of their areas is 176. So I want to get the area of the square and the area of this rectangle added together, and it'll give me 176. So the expression for the area of the square would be x times x, which is x squared. The expression for the area of this rectangle, well, we have to multiply it, length times width. So again, if you rewrite it out, you do the distributive property, the area of this rectangle would be x times x, which is x squared, and then x times 6, which is a positive 6x. So what we want to do is we want to add up their areas, because the sum of their areas is 176. I need to write the expression adding up those areas and setting it equal to 176. Simplify. Here I have like terms. X squared plus x squared is 2x squared. And then I still have plus 6x is equal to 176. So remember, guys, we had this entire unit on quadratics, solving quadratics, graphing quadratics, and you can use completing the square, you can use the square root method, you could use the quadratic formula. All of those methods, they will work, or you can even use factoring if it is factorable. In this case, I am going to be using the quadratic formula. So in the quadratic formula, I need to make sure that it's set equal to 0. So when you rewrite this, it'll become this equation. Now that it's set to 0, I can denote my A to be 2, B to be 6, and C to be negative 176. Now guys, remember your quadratic formula?
I love this story.
There once was a negative boy who couldn't make up his mind about attending this radical party. He was a square boy who missed out on the chance to chill with 4 awesome chicks. And it was all over by 2 a.m. So plugging in those values, we get x is equal to negative 6 plus or minus the square root of the quantity b squared. So 6 squared is 36 minus 4 times a times c, all divided by 2 times a, which is 4. Now we want to simplify what's underneath this radical. That simplifies down to the square root of 1,444. And actually, this number is a perfect square. You can take the square roots of 1,444, and you do get 38. So really, there are 2 answers so far. Okay, we have negative 6 plus 38 divided by 4, and I also have negative 6 minus 38 divided by 4. The value of this expression, negative 6 plus 38, negative 6 plus 38 divided by 4 gives you 8. And then you could also, negative 6 minus 38 divided by 4 does give you negative 11. However, the question is asking, what is the length of the side of the square? Can I have a negative length in Algebra 2? No. The only reasonable answer would be 8. So your answer would be 8 meters. Okay, number 11 is pretty much just a straight up read and interpret the graph. Here on the left side, on the y-axis, I have money. And over here on the x-axis, I have skateboards. And I have 2 lines. This line represents revenue, meaning how much they made, the profit per skateboard sold. And here's the cost. It costs money to make these said skateboards. Alright, so will the company have a loss or a profit when 50 skateboards are sold? So over here I have 50 skateboards. at 50 skateboards, the cost is over here, and the revenue is above the cost. So basically, if your revenue is higher than the cost, meaning you made more money than you lost, that is a profit. How much money did the company make when 20 skateboards were sold? So looking over here at your graph, when 20 skateboards were sold, the cost was higher than the revenue. They didn't make any. They actually lost money. They went from, let's say that this is 700 and this is 500. They actually lost $200. Number 3 says, how many skateboards were sold when $1,000 were made? All we have to do is look over here on the y-axis. $1,000, that is at about 60 skateboards. So when 60 skateboards were made, they made $1,000 of revenue. Number 4 says, when will the company break even? So break even meaning they neither lost any money nor gained any money, any profit. That's where they intersect. That is at about 30 skateboards. That's the end of part 1. We decided to break it down into 4 parts because this is going longer than expected. It is 40 problems. So see you in the next part.
So you really hold me ransom and then you don't have me do anything for anything. So I'm just like sitting here doing nothing.
Next time.